Welcome to Business Analysis Techniques. This is your online instructor, Diana Block, and this is our final week of the new course format, 6-week terms. And this is our final assignment that we're looking at. I want to go ahead and go over this. Since you do have a short week, I want to make sure you understand how to work this problem. So assuming that you will have read the chapter 11 that goes along with this, and that's going to explain everything in there, but I just want to point out a few things that students commonly miss on this. So we've got this activity chart here, and what you're going to put at the top is the earliest start time and the earliest finish times, the top of each box. Earliest start, earliest finish. Earliest start, earliest finish. Across all of the activities, the top is going to be the earliest you can start the project, and based on the earliest that you started, you'll determine the earliest that you could finish it. The bottom of each set of boxes, the boxes across the bottom, are the latest you could start the project, and therefore the latest that you could finish it. And so if we start off, for example, in activity A, there's no prior activity before you start activity A, so the earliest you could start it is day 0. You could start at the very beginning. You don't have to complete any other activities. And that's the same for activity B and C. There's nothing before it, so you could start these as early as 0. Now, how early can you finish it depends on how long the activity takes. So if you look at the table, it tells you how long that activity actually takes. And so the earliest you could finish it, for example, A, if you started at day 0, the earliest that you could possibly finish is day 2. And so you'll do that same analysis with activity B and activity C. Then you'll go on to the activities that follow those. Based on the fact that you have to finish C before you can move on to F, the earliest that you can start F is the earliest date that you can finish C. And the earliest that you can start D is the earliest that you finished B. And the same applies. The earliest you could possibly start E is the earliest that you could finish between A and D. Remember, for E, both of these activities have to be completed. A and D have to be completed before you could do E. So when you're going to evaluate how early can I start on E, you can't start it before both A and D are finished. Okay? And that's what also applies to activity G. You can't start this until F is finished. You also can't start it until E is finished. You can't start E until A and D are finished. You can't start D until B is finished. So it's not a lot of calculations here, but you're just having to follow the path in each box to get the earliest start and earliest finish times. So then, to get the latest starts and latest finishes, you'll do the same process, just moving backwards through the network. So you'll start off with the earliest finish time that you gathered from the top, and in order to move to the bottom, then you'll have to work backwards using that information. Start at the finish and then subtract the activity times so that you can see the latest starts and latest finishes for the network. So you'll have to work through those one by one. There's no shortcut on this type of problem. And so once you've done that, you'll be able to determine what is the critical path for this particular project. So the textbook will talk to you about what the critical path is and the finish time along that critical path. You'll be able to pick out which activities are on the critical path and list those there. Then you're going to find the slack times. So the slack times are just like it sounds, it's the time between the latest start and the earliest start, or the latest finish and the earliest finish. So you're going to subtract the earliest you can start from the latest you could start, and that gives you how much slack time you have for that activity. So each activity will have its own amount of slack time built in. Some will have no slack, so just be aware of that. There will be 0 slack time on some activities, but some activities will have slack time. And you want to find the slack time for the activities that are not on the critical path. So those critical path activities, there's no slack, but for the others, you can determine how much extra time you have available in your planning for the project. So that's how you're going to work that. And then when you get to problem 2 here, these are going to be more calculations. These are going to be calculations basically straight out of the book using the formulas for the expected time and the variance. Those formulas are given right in the textbook, so you'll use those exactly as they are given to calculate the slack time, the expected times and the variances. Now, I do notice for some reason, students will not completely finish the answer. For example, they will leave an answer of something like that, and that's not the final answer. If those were the numbers that you were dealing with, then you would finish it out and put the exact number. 4 over 11 is actually 0.363. That's what you would put as your expected time and variance. Again, those numbers are just examples, but I'm not looking for you to put something like that. I'm looking for you to put the actual expected time and the actual variance, whatever that number may be, and it's going to be, numbers with decimals. So don't just leave it as something divided by something. That's not a final answer. So once you get those expected times and the variances filled in, then you have some other information here. It tells you what the critical path is on that project. So you're going to find the variance of the project and the standard deviation. Now, the thing I will say to remember here is they're giving you the critical path for a reason. I noticed that sometimes in the past, students have used all of the project variances to get the answer here. And it shouldn't be all 7 of these variances combined. It should be the project variance, which is the critical path. So make sure you're only using the items that apply to the critical path in that formula. And so then you'll answer in part C if you have an expected completion time. And again, you've got the formula there to be able to calculate the probability for finishing in a specific number of days. That information is in the chapter and the PowerPoint. The formulas that you need are in the text. Then the last part of this is problem 3, where you're going to calculate crash costs. And so you will calculate the crash costs per week. And again, you just use the formula that's given. Calculate each one and then answer the questions below about which activity should be crashed. So my hint here is, remember that the crashed activity needs to be on the critical path. So the biggest mistake that I see in this in the past is that students will state that a cost should be crashed that's not on the critical path. And so that's not going to be the correct answer. You want to have the activity that has the lowest crash cost per week that is on the critical path. Not just the lowest crash cost per week, but the lowest crash cost per week that is on the critical path is going to be your answer down here. So those are the things that I see that students miss most often on these. So if you make sure you get those correct and follow all the formulas that are in the text, I'm sure you will get perfection on this assignment. Again, this is our last week, so that means everything has to be submitted by Thursday. So I look forward to talking with you in the discussion area. Feel free to send me an email with your spreadsheet that you're working on if you have any questions, and we will talk later. Have a great week.